This is the video solution to sample exercise 2.2 practice problem A that appears on page 45 of your text. The problem asks us to determine the number of protons, neutrons, and electrons in the following atoms. For part A, we're given a nuclide representation for an atom where we see 10 as the top number, 5 as the bottom number, and then the symbol for the element as B. The bottom number, 5, is the atomic number symbolized by Z, or the number of protons for this atom. So we can say that this particular atom of boron has 5 protons, as will every atom of boron. The top number is the mass number. That is the sum of the protons and the neutrons together. So since we already knew the number of protons, we can do some subtraction, 10 minus 5 protons, and decide that this particular atom has 5 neutrons. There's no charge shown in this particular nuclide representation. And since no charge is shown, we must assume that the positive and negative charges cancel one another out or are equal to one another. And since we already decided that this had 5 protons, then we will say that it has 5 electrons as well. Moving on to part B, we see another nuclide representation, only this time we're not given the atomic number. We don't really need the atomic number because we are given the abbreviation, the letter abbreviation, so we'll look up the atomic number for AR in the periodic table, and we'll find that this particular atom of argon, as all atoms of argon, will have 18 protons. We are given that mass number, and again that's the sum of the protons and the neutrons, so a little subtraction. 36 minus 18 will tell us the number of neutrons, and we'll get 18 for that value. And again, no charge is shown, so we will assume that the positive and negative charges all cancel one another out. We already decided that there were 18 protons, so we must say that there are 18 electrons as well. Our third example is given to us as 85, 38, and then SR. We use the same process that we used for part A. We can look at SR on the periodic table and decide that it has 38 protons. Again, that was shown to us by the atomic number. We know the mass number, and that will help us figure out the number of neutrons. So we'll take our mass number and subtract the number of protons that we have and figure out that we have 47 neutrons in this case. And then, again, no charge is shown, so the protons and the electrons must be equal to one another in terms of number. We have 38 electrons in this one. The final example in this particular practice problem asks us to worry about carbon 11. This isn't an actual nuclide representation, but we can still get the same information from what's written. As long as we know that we're dealing with carbon, we can look up the atomic number for carbon in the periodic table, and every atom of carbon will have 6 protons. The mass number is shown to us, that's that value 11. And again, some subtraction between the mass number and the atomic number will tell us the number of neutrons, so we can say that this atom has 5 neutrons. And no charge is shown, so the protons and electrons must be the same number. We can say that this particular atom has 6 protons, 5 neutrons, and 6 electrons. At this point, you should try to solve practice problem B on the same page in your text and check your answer against the solutions in the back of the chapter.